shared screen?
Yes.
All right. So let's start with something quite easy. So I'm pretty sure everyone should know how to do these. I know it might look like an insult to your intelligence to even ask this problem, but let's start with the area of the rectangle. This should be fairly obvious. What is the area of the rectangle?
10.
10, right? And the area of the triangle is
4.
4. And can we answer this word problem at the bottom?
80.
Sorry, can you repeat that?
80.
Yes, 80. All right, so this is some pretty elementary mathematics, right? I'm pretty sure we all learned this several years ago. It's not hard. So if we go a bit beyond elementary mathematics, we'll see something that is, we can start to see things that we can't do. So let's start with this, something that's possible. So a ball rolls along a table with a velocity given by the equation v equals negative 2t plus 7. What's the acceleration of the ball at t equals 3? So first of all, do we know what velocity and acceleration mean?
The difference.
Right, so velocity is the speed of the ball, right? And the acceleration is how much the speed is changing. All right, let me clear this. So to find the acceleration of the ball at t equals 3, it should be also fairly trivial if we graph the velocity over time. Very badly drawn. It's negative 2t plus 7. So something like that. Okay, my line is not so good. So, oh wait, no. Yeah. So what's the acceleration of the ball at t equals 3? So that would be here. And as you all know, acceleration is the change in velocity. So the question is really asking, what's the slope of this line at t equals 3? So can everyone answer that?
Three. Oh, is it 2? Negative 2?
Right, yes. The slope is negative 2. You can see this equation is in slope-intercept form, so it's negative 2. In fact, you can probably see it's negative 2 along the entire, this entire interval from 0 to around 3.5. It's supposed to be 3.5, but my line is not drawn so well. So this has a, hang on a moment, there's something. All right, so this is a somewhat trivial problem if you know how to do it. It's just negative 2 along the entire interval. Now let's try something that's not possible with just elementary mathematics. A ball sinks down a swimming pool with the velocity given by the equation v equals negative 3t squared. What is the acceleration of the ball at t equals 3? So we can graph this again. The velocity is negative 3t squared. I should have really brought a bigger graph. Yeah, let's, for the sake of simplicity, because that won't fit on the graph, let's just do negative t squared. So if we graph this velocity, you can see it forms a parabola, and That should have been obvious if you know from algebra that this square here will make it a parabola. But then if we ask what's the acceleration of the ball at t equals 3, it's not so obvious anymore because this doesn't have just a constant slope. So this is where calculus comes in. We cannot find what the slope of this curve is at t equals 3 because if you think about it, it doesn't really make a lot of sense to find the slope of a curve at any given point. So let me get a whiteboard. And if anything is not making sense, feel free to say in the chat or unmute yourself. Okay, can everyone see the whiteboard?
Yep.
All right, so let's say we have some sort of line, right? Let me change the color here. And we have a line, all right? It's easy to find the slope of this line. But if we have some sort of curve, as I showed before, it's not really that meaningful to say, oh, what's the slope of the curve at this point, right? Because it's not flat. So the point of calculus, or at least differential calculus, is that we're able to use a concept called limits to find slopes of curves. We can even find equations for slopes of curves because you can see the slope does change. You know, it's a bit shallower here and then it's much steeper here. Then it gets shallow again and it goes the other way. So obviously you can see the slope changes. So we would have some function. So is everyone familiar with what a function is?
It's when you put a number into a function and then it comes out.
Right, that's a pretty good explanation. So a function takes in some input and it spits out some output. We'll call that y, right? So we have a function that gives the line of this, that gives this curvy line. Let me just delete the straight one. This curvy line is some function, right? We'll call that f of x. To find the slope of this line, we would need to introduce a concept called the derivative as well. So the derivative, or we can write that as f prime of x, is the slope of this curve. And I'll teach you guys how to find, or rather we don't usually write y, we usually write y prime. I'll teach you later on how to find derivatives of functions. For now, we just need to know what a derivative is. Now let's get on to start from the basics, from what we need to know to learn the derivative. The derivative, to learn the derivative, we first need to know something called the limit. And to know the limit, we need to know something called continuity. So continuity is a concept in maths of functions. So let's draw some function here. This is a continuous function, meaning it doesn't have holes in it. That should be a pretty simple thing to understand. A continuous function is one that doesn't have holes or gaps or any sort. I'll give you an example of a non-continuous function. Does anyone know what this function is called? Or what this shape is called? If not, that's okay. So this is a rough sketch of the graph of f of x equals 1 over x. So this is an example of a function that is not continuous at this one point, this x equals 0, and you can kind of see why it's not continuous at that point, because it's not defined at that point. Because if you put in 0 for x, f of 0 is 1 over 0. Well, we can't do that, right? So that's what it means for a function to be continuous. Try and get the pen back again when it keeps going to the eraser. I'm sorry, it's kind of hard. So let me draw a few functions here, and then y'all can tell me whether they're continuous or not. Okay, can everyone tell me which one of these functions are continuous and which are not? You can put your answer in the chat. Okay, so Jin says the yellow and the red ones are continuous and the blue and the green are not. Gracie says the blue ones are not continuous. Or are you saying they're continuous or not continuous?
No.
No. So you're saying the blue ones are not continuous. What about the red ones, the orange ones, and the green ones? Are they continuous?
The green ones are not, but the yellow and red ones are.
Right. And I encourage everyone to at least try this. There's no penalty for getting it wrong or anything. So feel free to put in the chat which ones you think are continuous and which ones are not. Okay, so Claire says the green one is not continuous. Right, still haven't received answers from most people, so please put something in the chat. Even if you say, I don't know, that's all right too. Let me just write down the definition of continuous. Okay, I don't think I'm going to get any more responses. So I'll say it. So a continuous function, again, is a function with no gaps or jumps. This green one has a gap. Has a gap here, right? So the green one is not continuous. So let me say green one, not continuous. So what about this red one? This red one is continuous because it has no jumps or gaps. It's just a smooth curve. So this red one is continuous. What about this orange one? This orange one has a sharp point here, but it doesn't disconnect at that point. It doesn't, it doesn't jump. So this orange one is continuous. This blue one here, this one has a jump. It doesn't have any gaps. It's not like it's not defined at this point. It is. It's defined to be this. But it has a jump, and for that reason, the blue one is not continuous. All right. Oh, forgot to mention, we're going to take a short break at 10:30, 5-minute break. So the idea of a limit is we try to figure out what a function approaches as you get closer and closer to a certain point. So let's draw a coordinate grid here. All right, does everyone know what the circle means? This circle here in the middle.
Origin.
Right, yes, it's at the origin, but do you know what an empty circle means in a graph? So an empty circle, right, Claire says it means not included. So an empty circle means it's not part of the curve. So in other words, there's a hole there. It's just a single point hole, so it's infinitely small, but it's a hole. So this is the graph of f of x is just x. This is a very simple graph. We can use the idea of a limit to sort of assign a value to this hole, even though this hole is not part of the function. And that's what we call the limit, or just lim for short, of f of x. And we say this is equal to some number. We can find technically the limit at any point. So we could find the limit, say, at here. So the limit at x equals 1, since it is actually defined at that point, it's just the value of the function. When it gets interesting is when you use the limit for points that are not defined in the function. So we can say the limit at this point, we can write that as the limit as x approaches 0. I did want to mention that this is f of x equals x, but x isn't 0. Just to, not include the middle point there. So we can find the limit as x approaches 0 of f of x is some number n. And again, it should be sort of obvious what it is. So if we think about getting closer and closer to this point, what number does it approach? So can everyone tell me what value does the red line approach as it gets closer and closer to this middle not included point?
0.
Right, 0. So we can say the limit as x approaches 0 of f of x equals 0. All right. So that's pretty simple. It's now 10:30, so we can take a 5-minute break now. All right, everyone, welcome back. So that was a bit of a sample of how teaching might happen in this course. I'm now going to show you the course syllabus and how we can do homework and how to contact me if you ever need help with anything. And we'll get back to the results of the pre-test that I hope all of you took was in the WeChat group. All right, so this is the course syllabus. Can everyone see the screen, by the way? Hello? All right, see some reactions. All right, so here's a course syllabus of what we'll be doing week by week. Today was supposed to be the course introduction, but I went a little bit into continuity and the limit. And we'll talk about how to access our course Padlet and how to turn in homework. So does everyone know what Padlet is? Please state in the chat if you've never used Padlet before. Okay, so Claire hasn't used it before. That's all right. So we can get to Padlet at padlet.com. I've already signed in, but you will need to sign in with an account if this is your first time. But I'll share a link to our course Padlet, Basics of Differential Calculus, in the WeChat group, and the poll just pops up. Please answer how many questions you got right on the pretest in the poll. So using Padlet is pretty simple. Every week I'll post the homework here, and so every week I'll post the homework here, and there will be a button to which you can reply, and you can upload your homework if you, like, say, did it on a piece of paper, or if you did it on the computer, you can upload the file. And I would like everyone to upload their homework by the end of the day, Sunday, every week, so we can get a chance to review it before the study session on the study session on Monday. So here on the Padlet, you can also see that I've included a link to the textbook. The textbook is completely free. You don't need an account or anything. So let's open it now. And we're not going to be just reading from the textbook per se, but I will be using the practice problems from it. So you should know how to access it. The book is called LibreText, or it's on LibreTexts. And here it's chapters. So we can go here. And then here's a bunch of the pages. We're not going to be going through all the pages, but it's also here if you need some extra supplemental text. And don't worry if you didn't really understand what we went through today, because I'll go through it again tomorrow, or not tomorrow, next time, in a lot more detail and hopefully explain it better than I did today. And if anyone needs help with anything during the week, I'm always available on the group WeChat. You can just leave a message and I'll try to respond as soon as I see it. I check it several times a day. And that's pretty much it. So let me check the poll now. Has everyone answered the poll? I see there's still 2 people who haven't answered the poll. So if you haven't done so yet, please just pick an answer on the poll. And there's no shame, it's completely anonymous. If a lot of people haven't got all the answers correct, that's all right. We can just slow down a bit. So if you haven't answered the poll yet, please answer it. All right, so the poll results have just come in. Looks like a lot of you are in the middle section with a fair bit on the upper and lower ends. So I'll go a bit slower this course, so you can all get a chance to understand the content. Again, if there's at any point you don't understand, feel free to either post it in the chat that, oh, I am having a bit of trouble understanding. Can you repeat this point? Can you say it a different way or a bit slower? There's no shame in asking questions. We're all here to learn. Claire says, I don't think I had access to the pre-tests. It was in the group WeChat. Did you check the group WeChat? I'll put a link in the Zoom for you all if you haven't gotten to the pre-test yet. No, let me go get it. So I've put a link to the pre-test in the chat if you all want to try it a little bit later. All right, so during the course, if I don't get enough responses from people, I will call on you. So please make sure you're actually present and not just logged into Zoom doing something else in the background. There will be a study session every Monday between 8 and 9 p.m. Eastern Time. You don't have to attend it, but I highly recommend if you do come, if you want to review the work you've done, and I'll be offering some homework help and all that. Also, I'll be teaching some neat tricks during the study sessions as well, so please come. Classes will be held between 1 and 2 p.m. Eastern Time every Saturday, so seeing that you all actually made it to this class, I'm pretty sure you'll all got that down. All right, so there's not really going to be, any homework for this class because this is just the introduction. However, I will post something on Padlet that I would like you all to respond to. So please check that after the class. I'll post it shortly thereafter. And that's pretty much it for now. I'll give you a few practice problems to think about, just so we can review a bit more about what I've gone through today. Is everyone able to see this all right? Please post in the chat if you're having some issues seeing this.
It's sort of cut off.
Sort of cut off. All right, I'll clear the whiteboard and start over. All right. Is the line straight?
There's 3 separate lines and one is kind of above the others.
All right, since the whiteboard's a bit messed up, I'll go search for some problems in the textbook. All right, so the link to the Padlet was posted in the chat. Does everyone have that? And can everyone get into Padlet? So is anyone having trouble getting into the Padlet, or is everyone all right? All right, so I've pulled a few problems from the textbooks. So it's from chapter 2.4 on continuity, and here are the problems. So this is, again, these problems are pretty simple. Is this continuous?
Yep.
Right, Grace says it is. Or Gracie says it is. Anyone else? All right, I'm going to call on someone. Sean, can you tell me whether this function is continuous or not?
This function is continuous. It just keeps on going.
So you're saying this function is continuous, all right? So can you explain why do you suppose it's continuous, besides just saying it keeps on going? So what can you recall what the definition of continuous is?
I actually don't remember what the definition of continuous is. I didn't really join until like a little later, so yeah, I didn't really hear it.
Oh, that's all right. So a continuous function is a function that has no jumps or holes.
Oh, so this one isn't.
Yeah, so this one isn't. Well, why is it not?
There's a hole.
Right, yeah, there's a hole here. On top of that, there's sort of a jump here, right? So because there's a jump here, this function isn't continuous. And another quick way of remembering whether a function is continuous or not is, could you draw the function without lifting up your pencil? And this one you couldn't, because you would have to lift up your pencil after you finish drawing this part to get to this part. All right, let's move on to the next one. Is this one continuous?
Yes.
Okay, Gracie says it is continuous. Can anyone else answer?
No,
Sorry, who was that?
no,
Okay, Jennifer says it's not continuous. Can you explain why this is not continuous?
because there's a hole. It's not continuous.
Right, because there's a hole, it's not continuous. All right, let me just check if anyone else can answer it. Danny, are you here? Danny? Danny, can you tell us, how could we make this function continuous? What would we have to do with it, do to it? Okay, I don't think Danny's here. All right, what about Leon? Is Leon here?
Yeah.
All right, can you tell us what would we have to do to this function to make it continuous?
I'm not sure.
Not sure? That's all right. So again, a function is continuous if it has no holes or jumps, right? Leon, are you still here?
Yeah. We would have to get rid of the hole, right?
Yeah, you'd have to get rid of the hole. So if this hole were sort of filled in, I guess, is it now continuous?
Yes.
Or is there any? Right, there's nothing else that disqualifies it from being continuous. So let me just write the definition of continuous again. Okay, so can everyone see the drawing? All right, so that's basically all I want you all to take home today. Just the definition of continuous, and I hope you all know how to access the Padlet. Again, the Padlet will be posted in the group WeChat. And apologies if my speaking today is a bit scatterbrained. I'm a bit tired. Sorry. So, and yeah, make sure to check the Padlet a bit after class as well, because I'll post something I would like you all to respond to. And I'll post all the other materials as needed up there too. All right, thank you everyone for coming. That's all I have.
Thank you.
All right. If anyone has any questions, feel free to stick around and ask them.
请问大家有没有什么问题呢？是不是太难，或是追不上，或是觉得太容易啊？你们可以 unmute 自己，是不是啊？Do you guys have any questions? Is this too easy or too hard?